Imagine this: about 4.6 billion years ago, a colossal molecular cloud collapsed under the force of gravity. This dramatic event marked the birth of our solar system. As the cloud collapsed, it began to spin and flatten into a disk, much like a spinning piece of dough. At the center of this whirlpool, where the majority of the cloud's mass was concentrated, the sun began to form. The rest of the disk wasn't idle either. Particles within it started to collide and stick together, setting the stage for a cosmic ballet of creation. Over time, these particles grew into planetesimals, the building blocks of planets. Closer to the sun, these building blocks formed the terrestrial planets: Mercury, Venus, Earth, and Mars. Further away, they clumped together to create the gas giants, Jupiter and Saturn, and the ice giants, Uranus and Neptune. Intermingled with these emerging planets were countless smaller bodies, the asteroids and comets that still wander our solar system today. So, from a massive cloud of dust and gas, our home in the universe was born. At the heart of our solar system lies the Sun, a fiery giant responsible for life as we know it on Earth. This colossal ball of hot, glowing gases is the ultimate powerhouse, with its nuclear furnace converting hydrogen into helium, releasing energy in the process that lights up our world and fuels life itself. The Sun's intense gravity keeps all the celestial bodies in our solar system in check, orchestrating their orbits in a cosmic dance across the eons. But the Sun isn't just about light and life. It's also a volatile, dynamic entity, one that's constantly belching out streams of charged particles in the form of solar wind. These solar winds shape space weather, influencing everything from satellite operations to the dazzling display of auroras at our poles. And what of the Sun's future? In about 5 billion years, it will exhaust its hydrogen supply and swell up into a red giant, ultimately shedding its outer layers and leaving behind a white dwarf. This transformation will drastically alter our solar system, a testament to the Sun's central role in our cosmic story. In all its blazing glory, the Sun truly is the lifeblood of our solar system. Beyond the Sun, 8 diverse planets orbit, each with unique characteristics and fascinating features. Closest to the Sun, we find the terrestrial planets: Mercury, Venus, Earth, and Mars. These rocky bodies each possess their unique quirks. For instance, Venus, the second planet from the Sun, spins so slowly on its axis that its day is longer than its year, a phenomenon known as superrotation. Further out, we encounter the gas giants: Jupiter, Saturn, Uranus, and Neptune. These behemoths are primarily composed of hydrogen and helium, much like our Sun. One of the most striking features among them is Mars's giant dust devils, towering whirlwinds that sweep across the Martian surface, reaching heights up to 50 times that of their terrestrial counterparts. From rocky terrains to gaseous atmospheres, the planets of our solar system are testament to the universe's diversity. Planets might steal the spotlight, but let's not forget the solar system's other inhabitants: dwarf planets and moons. Dwarf planets, much like their larger counterparts, orbit the Sun. However, they're too small to clear their orbits of other debris, which is why they don't quite make the planetary cut. A prime example is Pluto, once considered the 9th planet until its reclassification in 2006. This icy body, along with others like Eris and Haumea, reside in the frigid realms of the Kuiper Belt, far beyond Neptune's orbit. But what's a planet, dwarf or not, without its moons? Earth has one, Mars has 2, but some gas giants boast dozens. Saturn's moon Titan stands out among the crowd. It's the only moon known to have a substantial atmosphere, and more remarkably, lakes. But these aren't your average lakeside retreats. They're filled with liquid methane and ethane, a sight to behold if you could withstand Titan's frigid temperatures. Though often overlooked, these celestial bodies add depth to the solar system's complexity. Between Mars and Jupiter and beyond Neptune's orbit lie 2 cosmic highways: the asteroid belt and the Kuiper Belt. These regions are more than just a collection of floating rocks and ice. They're significant parts of the solar system's structure and history. The asteroid belt, a vast ring of rubble between Mars and Jupiter, is like a cosmic museum, preserving relics from the early solar system. It's home to millions of asteroids, remnants of the raw materials that helped form the inner planets. Ceres, the largest asteroid, is so large that it's classified as a dwarf planet. Beyond the realm of Neptune, we find the Kuiper Belt, a frozen frontier of icy objects. This distant region is a treasure trove of ancient icy bodies preserved from the solar system's infancy, like Pluto, the most famous Kuiper Belt inhabitant. These cosmic highways are not just empty space, they're bustling with activity. They house objects ranging from tiny grains of dust to dwarf planets, each with their own unique story to tell. These cosmic highways are a testament to the solar system's dynamic nature. Our solar system doesn't exist in isolation. It's a part of a vast, interconnected cosmos, and occasionally we get visitors. Interstellar objects from different corners of the cosmos have paid us visits, offering intriguing insights into the nature of our universe. They're like cosmic voyages, traveling billions of miles, crossing the unfathomable void of space to reach us. These celestial nomads are not bound by the sun's gravity, and their journey through our solar system is but a fleeting moment in their eternal voyage. But where does our cosmic neighborhood end and the rest of the universe begin? The answer lies in a term known as the heliopause. This is the theoretical boundary where the sun's solar wind slows down and merges with the interstellar medium. It's like the edge of a cosmic bubble, enveloping all the planets, asteroids, comets, and other objects that make up our solar system. But it's important to understand that this boundary isn't a hard line in space. It's more of a fluid, fluctuating frontier, influenced by the sun's activity. When the sun is more active, the heliopause expands. When it's less so, it contracts. This fluid border, this heliopause, is our solar system's ultimate frontier, the line that separates us from the vast, uncharted territories of the cosmos. It's our gateway to the stars, the door to a universe filled with mysteries waiting to be unraveled. These interstellar encounters and borders remind us of our place in the grand scheme of the universe. The solar system is not just a celestial neighborhood, it's a frontier for human exploration. Our species, ever curious and driven by an innate desire to push boundaries, has embarked on a journey of cosmic proportions. Our venture into the unknown began with the Moon, our closest celestial neighbor. The moon landings of the mid-20th century marked a significant milestone in human history, demonstrating our capability to reach beyond our home planet. But the Moon was just the beginning. Since then, we've sent robotic emissaries to every corner of our solar system. From the rovers trudging through the Martian dust to the probes that have ventured to the outer giants, these machines have been our eyes and ears in the cosmos. We've seen the fiery volcanoes of Jupiter's moon Io, the icy geysers of Saturn's moon Enceladus, and the blue skies of the dwarf planet Pluto. These missions have revealed a solar system that is vibrant, diverse, and teeming with potential for discovery. But our journey doesn't stop there. Plans are underway to send humans to Mars, and probes are being designed to explore the icy moons of Jupiter and Saturn. These missions promise to answer fundamental questions about our solar system's past and its potential to harbor life. As we push further into the cosmos, we carry with us a sense of wonder and a thirst for knowledge. Each discovery, each new horizon, brings us a step closer to understanding our place in the universe. With every venture into the unknown, we learn more about our place in the cosmos and the secrets it holds.